Hey everyone, very good evening. I welcome you all to this virtual meeting. As Matt said, I hope COVID will be over soon and everyone will be back for in-person meetings. I hope you and everyone in your family are staying safe and healthy. I always feel so happy to be part of this user group. Matt and Brian, thanks for having me here again. You guys always give me an opportunity at least every year, once a year, for me to come and connect with this wonderful community. So thanks for that. And as everyone know, Matt did mention about it. I'm going to talk about durable functions today, which is an extension on a service called as Azure Functions, uh, which lets you write stateful code in serverless environments in Azure. The session is going to be a level 100 to 200. I cannot go for a deep dive in 60 minutes, but what I'm trying to do is to cover some basics so that if you haven't heard of Azure Functions or durable functions earlier, it won't be a prerequisite. You should be able to grab what I'm going to say. And if you have already worked on Azure Functions before, then also you will learn something new. I'll talk about some concepts on durable functions, show some quick demos. And before we jump onto agenda, let me introduce myself. I know Matt did mention I've been speaking at this user group since 2017, so not a new face, hopefully, for most of you, but still, if you don't know me, my name is Vaibhav Gujral. I work at Kivit as a cloud architect. I'm a Microsoft Azure MVP and a Microsoft certified trainer. I'm a Microsoft certified Azure Solutions Architect, and I have a few other certifications. As Matt was saying, I do run Omaha Azure User Group. If you are interested in learning more about the user group, please feel free to visit the website omahaazure.org. I regularly speak at user groups like this one and other events and conferences on Azure related topics. I regularly blog on my blog address that I've listed there, and I'm trying to bring up my YouTube channel as well. If you have to reach out to me, feel free to do so on my Twitter handle, or you can also reach out to me on LinkedIn. With that, let's get started. Uh, as I said earlier, this is gonna be a level 100 to 200 session. We'll start with the very basic around what is serverless. We'll talk about Azure Functions and see a few concepts around Azure Functions. We'll talk about some of the challenges that Azure Functions poses and how durable functions can help us solve those challenges. We'll talk through different concepts in durable functions. We'll talk about different patterns that we can implement using durable functions like function chaining and fan out, fan in. As I said, I have planned few demos as well, and I would like to cover as many as possible based on whatever time permits. And last but not the least, even though I would like this to be an interactive session, I know Matt did mention please stay on mute uh, to avoid distraction for others. But if you have anything to contribute, to ask, you have a question or a comment, feel free to raise your hand and I'll get back to you. I have the chat window open towards my left on my third monitor, which I'll keep checking occasionally for any messages. So if you have any messages, feel free to post it on the chat as well. I'll try to get back to that. I have over 40 slides and few demos that I want to cover in next 60 to 75 minutes. And that's why I will not be able to answer everything in between, but I'll try to answer. But just in case if there are still more questions, I'll not mind hanging out after the presentation. So with that, let's keep going. I hope everyone in the group understand different cloud deployment models. If not, here is a refresher. Before public cloud came in, everything used to run in traditional on-prem data centers where we as a consumer used to manage everything from physical infrastructure ranging from racks, servers, network switches to the virtualization and operating systems. We were also responsible to manage middlewares, runtimes, and last but not the least, we were responsible for managing applications and data that also resides in the data center. Then as we started making move to public cloud, be it Azure or AWS or GCP or any other public cloud, we started adopting a shared responsibility model. So unlike what you see towards the very left in traditional on-prem environment, when we move to public cloud, some of the things are managed by cloud providers, some of the things are managed by us as consumer. So the first deployment model that is closest to an on-prem data center is infrastructure as a service. Under infrastructure as a service, the cloud vendor manages all the physical infrastructure and the virtualization layer. We as consumers manage the operating system, the middlewares, runtimes, and certainly the applications and data that we hosted in those IaaS services. So AWS, Azure, GCP all offer infrastructure as a service offerings. In Azure, we have it known as virtual machines where we can host our workloads and we are responsible for manage operating system and all the layers above that. The next deployment model is platform as a service, in which we don't have to worry about the underlying operating system or the runtime or the middlewares. We just worry about our application and data. So one of the example could be app services where we just deploy our applications, but we don't really worry about the underlying nitty-gritties of how the infrastructure is managed and provisioned. And last but not the least is software as a service where we just consume application and data over internet. We don't really manage anything in the stack. Office 365 is an example of software as a service. So now how does that translate it for developers? So with the advent of cloud computing and the different deployment models that we saw in the last slide, there are different service models we can opt for to run on our applications. To start with, we can run our workloads in bare metal machines in our own data center. Since it is on-prem, everything is owned and managed by us. The next evaluation came with infrastructure as a service in the form of virtual machines, where, like what I have shown in last slide, we had to manage operating system and runtimes and code, and virtualization and physical servers were managed by the cloud provider. The next evaluation came in the form of platform services like app services, where everything under the platform is managed by the cloud vendor, and we are just concerned about our application code and making it run in that platform. And the most recent advancements came through serverless architectures, where we just manage and worry about our application code, and we don't have to worry about anything else as it is managed by the cloud vendor. So in Azure, we call it functions. In AWS, it's called Lambda, but essentially the concept remains the same. So the question is, what is serverless? Let's quickly talk about it. When we say serverless, it doesn't mean that there is going to be no server. It essentially runs on server. Any serverless workload, any serverless architecture that we speak about, it still runs on a server. What it really means is we don't have to worry about the underlying infrastructure, because the servers, the infrastructure, the operating systems, the platform, it's all abstracted away. We just deploy our code and it just runs, and that code could be just as simple as a function. And what we are going to talk about today is a function as a service offering from Microsoft known as Azure Functions, and a specific extension of it known as Durable Functions. Before we jump onto those, it's important to understand the benefits that we can get out of serverless architectures. We all would have come across situations where we would have deployed our resources or deployed our applications on any hosting platform, and we would be running all our servers 24 by 7 up and running, just so that we can handle the load whenever the requests come in. But the request might just come in for an hour every day or a week or every year, but we still used to manage or keep those servers handy. But serverless actually takes away those nitty gritties. We are built essentially for just the execution time whenever our code is executed, and each of those individual independent code blocks can be I relate it to essentially normal methods, C# methods that we write. Functions are not different from those. uh, I was reading, I don't remember the book, but it clearly said a function should have a single responsibility. It should not do more than one thing. So that essentially even applies for any serverless function, Azure function. Let me pull up the next slide. So, and as I said, in Azure, the serverless compute service uh, in Azure is known as Azure Functions, that runs code on demand. We call those small pieces of code as functions. Uh, just think of in terms of, like, if you are working on a problem at hand, let's say it could be any small problem that you're working on. You can deploy a solution for that problem as a function in Azure rather than worrying about whole application or the infrastructure to run it. Azure Functions does offers out of the box templates for some of the most common scenarios. It could be connecting to a storage, image or video processing, exposing APIs, Internet of Things, running a script or code in response to a variety of events. And each of these are single unit of functionalities that are present in every application. We can actually have different functions for each of them and run them as a separate piece of code in Azure. The advantage we get out of is each of them then have independent life cycles. We can deploy them independently. They can have their own CI/CD pipelines independent of others. If you have used app services in the past, which is a platform service where we can host our websites, there used to be a feature called web jobs to run background jobs. So think of Azure Functions as a serverless evolution for web jobs. I wanted to run through some features for Azure Functions fast. It does support a bunch of programming languages. I know this is a .NET user group, so C# is probably what most of the folks present here would be using, but Azure Functions does support F#, JavaScript, Java, PowerShell, TypeScript, and Python. And as I was saying, it's serverless, so we are only charged for the time our code is executed. We are only charged for the execution time. It does support NuGet and npm packages. If you are using HTTP trigger-based function, it does have OAuth support. Since it's part of Azure ecosystem, it supports most of the other Azure services for integration. Uh, it offers a flexible development environment because, as I said, each of these functions have their own independent life cycle. So if I'm part of a development team, I can write a function in C#. My colleague can write a function in JavaScript, and they can still technically talk to each other. And a good part is Azure Functions Runtime is open source, so you can go and find the repo in the GitHub, and if you want to contribute, you can contribute as well. But the primary takeaway is the best benefit that you get out of Azure Functions is that you are only charged for the execution time and not beyond that. I'll talk about the pricing in a little moment, but just take a note of that. Here's a quick snapshot of different languages that are supported by different versions of Azure Functions. Uh, as I said, C#, JavaScript, F#, Java, PowerShell, Python, TypeScript are supported. Starting .NET 2.0, Azure Functions and moved from .NET Framework to .NET Core, making it more cross-platform. Hence, you can see support for Java and Python coming in there. So if you want to utilize Azure Functions platform for any of the other service, any languages, feel free to do so. You can always refer to the link that I have listed down below for the up-to-date list of supported languages. As I was saying, functions can be integrated with different Azure services, some of the third-party services as well. These services can either trigger a function execution, or they can also serve as an input or output for the function code. Here's a screenshot of some of the services that Azure Function can be integrated with. It ranges from Cosmos DB to Event Hub, Service Bus, IoT Hubs. It can also integrate with third-party services like Twilio for SMS integration, SendGrid for sending emails, Kafka, and Dapper, and external webhooks as well. I wanted to run through life cycle of an Azure function, how it works. So essentially, it starts with a trigger, and which is triggered by an event. Whenever there is an event that takes place, it triggers a function. It could be messages received in the service bus. It might be a timer trigger. It might be a webhook call, or it might be a message that shows up in storage queue, or if entity is shown up in a table, a storage table. We can have all those bindings, and we can have triggers for most of these services that I was showing here. So once we have a trigger established, it triggers a function code to execute. The function code executes based on the trigger, gets the input from the trigger, and it returns the output. That's pretty much is the life cycle of a single Azure function. So I was doing some preparation for this particular slide presentation, and I came across this video. I have provided a link for that, and I never knew that how the Azure Functions icon or the logo came into existence. But essentially, going back to this, the only two pieces of interest here is an event which triggers a function, and the code that gets executed. So essentially, code plus events resulted in Azure Function logo. So which was, I never knew that. So I thought I will share it with the group here, which was kind of interesting. Anyways, I did mention about the triggers earlier, that an event is something that triggers a function. There are different out-of-the-box templates available that you can use to trigger your Azure functions, which can tie back to all the services I was showing you earlier. Don't want to go into too deep here because we have plans to talk about durable functions today, but just a refresher on supported triggers. We can have HTTP, timer, Cosmos DB, all different kind of triggers that for related to the services I was showing you earlier. Similar to triggers, there is a concept called bindings in Azure Functions, which are a declarative way to make data available for your function from external services. It could be an input binding, or it could be an output binding. We can also have a binding which works, which is bidirectional, meaning in and out. Here's an example of how bindings are defined in the JSON host.json or the function.json file, where the first binding is an in binding, which is for a queue trigger. Whenever a message shows up in our queue, it triggers our function. And the other binding is for a storage table, which is of type out. Here's an example of how an Azure function looks like. We have function name attribute to declare that this method is a function. We define a trigger type to specify the configuration of how our function gets triggered. In this case, it's a queue trigger. It gets triggered every time message is written to my queue items queue. And these are the connections that come from the bindings that I was showing you in the last slide. So there are three pricing plans, as I was saying. I will talk about pricing later. Here's the how Azure Functions are pricing works. To start with, there is a consumption plan in Azure where, as I was saying, we are charged for the execution time. It's the default hosting plan. Uh, the next one is premium plan. When we talk about consumption plan, there have been issues reported for uh, cold start. For example, whenever a function is executed, it goes to sleep after remaining idle for some time under consumption plan. And whenever the next request comes in some scenarios, it might take some time to warm up and respond back. So that scenario is handled through premium plan where they keep perpetually warm instances just to avoid any cold start. I'll talk in the next slide how consumption plan and premium plan pricing differs. Uh, but that's one of the features that is available in premium plan. If you go with consumption plan, be aware of the cold starts in some of the scenarios. Premium plans also support virtual network connectivity so that you can connect your functions to your virtual networks. That's not available in consumption plan. The last is the dedicated plan, in which you get dedicated infrastructure to run your Azure functions, which is similar to running a web app on your app service plan. And when you are running a function in an app service plan, don't forget to enable always on, which keeps the function app running. This is how it looks like under the hood for the consumption plan. There is a component called a scale controller in Azure, which keeps on monitoring all the events uh, for, for the appropriate trigger that has been set for the function. The scale controller uses heuristic for each of the trigger types. So for example, if you are using Azure Queue Storage trigger, it will look into the queue length and the age of the oldest queue message. Based on that, it does scales up or down the function host instances. Function host is nothing but what you see as a function app if you have worked in the with functions earlier. Otherwise, I'll show you what function host is. Essentially, a function host can be combination of multiple independent functions. Here's how the pricing looks like for the consumption plan. Basically, it measures two things: execution time, which is measured in gigabyte second, and then the total number of executions. If you'll pull up Azure pricing calculator, that is how it comes up. You can provide the memory that your function will need to process different requests, and then how much each of the requests might take time, and then how many number of executions do you expect to have every month. Now note that the first 400,000 gigabit second of execution and first 1 million executions are free, but overall Azure function consumption plan is very cheap, as you can see, for 2 million executions, each taking us 1 second and 512 MB of memory. It's gonna cost me little under $10 a month, which is kind of cheap. Moving to premium plan, as I was saying, it does uh, offers a perpetually warm instance, meaning it always keep an instance up and running. So hence the pricing model differs for the premium plan than the consumption plan. You always end up paying for at least one instance under premium plan. It's built based on a couple of things: the number of cores and the memory. And as you can see, the pricing for that, you can always check Azure pricing page for the latest updated pricing. But just to give you a context, what I'm trying to talk about is how the dedicated or premium versus consumption plan might differ. As you can see, if I go for a dedicated or a premium plan, I sign up for a fixed cost. Let's say if it was $40, then regardless of my work or my executions, I pay a fixed price across the time frame. But if I'm in consumption plan, as you can see, if I don't have any requests or any executions, I don't pay a single penny. But then depending upon how many executions I have, I pay for that. So over the long term, if my executions vary at different times, moving to consumption plan makes lots of sense to save dollars. If you want to get started with Azure Functions, ensure that in Visual Studio 2019, you have Azure Development checkbox checked while installing it. This will install all the required Azure Functions SDK and the tools that you will need to develop your Azure Functions. If you are using Visual Studio versions older than 2017, then you might have to install those extensions and tools separately through the extensions in Visual Studio. Anyways, once you install your Visual Studio with Azure Development Tools, then you will start seeing a template for Azure Functions in Visual Studio that you can use to create your functions. If you are a Visual Studio Code user, you will need Azure Functions extension. I provided a link down below which you can use to install the extension on Visual Studio Code. The other thing that you will need for running and locally and developing, testing, and debugging your functions locally are Azure Functions core tools, for which I have provided the link again as well on the bottom. So as I said, version 1.x is all the older versions, version 1 and before version 2 came in, were built on .NET Framework, and hence they were supported on Windows. But starting version 2.0, it came on .NET Core, and hence it supports cross platforms, and you can install those on Windows, Mac OS, or Linux. Let me quickly go to Azure portal and see how you can get started with an Azure function. I'll go to new project here. I already have installed Visual Studio 2019 with the Azure Development Tools, and so I'm seeing an Azure Functions option here. I'll click on Next. I'll give a name to it. And it does ask me to select an appropriate trigger for now. As you can see, it does offer one for durable functions, which I will demonstrate a little bit later. But as you can see, there are different categories. We can start with an empty function project, but we can use any of the other triggers based on our use case. For this purpose, I will go ahead with HTTP trigger. You can always use any of the function versions here, v1, v2, v3. As I said, v1 works on .NET Framework. Version 2 and version 3 work on .NET Core, so you can choose whichever applies for your use case. Azure Functions uses Azure Storage at the backend to store some of its metadata. So you can either use Storage Emulator. I already have Storage Emulator installed on my box. If you haven't, you might have to install it if you want to use local storage. Otherwise, you can always go ahead and select an Azure Storage account. And then you also have to provide an authorization level to make your HTTP trigger secure. You can, based on the option that you select, it will provide appropriate key that you can use to authenticate your calls. Anyways, clicking create, it will create the boilerplate code for me for a HTTP based trigger. As you can see, it comes with an HTTP trigger. I have chosen authorization level as function, so I can use a function level key to authenticate my get and post calls. It takes a name from the query parameter and responds back. If my name is not empty, it responds back with my name saying that function was triggered successfully, else it says there was no name. So if I go ahead and simply click on run, it will spin up my Azure function runtime, which will run my Azure function locally, and it does exposes a function URL. I'll go ahead to a browser and run this, and as you can see, it did triggered my function. I'll go back to function here, and as you can see, it did my function HTTP trigger function did process the request, and it did executed the function, but I didn't pass the name. So if I go ahead and as you can see, if I pass a parameter, it does executes, and I can go and look into the function runtime that my function was executed again. And now this function runtime is exactly the same runtime that runs in Azure executing our Azure functions. So we are essentially in this similar environment that is out there in Azure. I'll go ahead and stop this. As you can see, it does creates a function app within which it's a, when we'll go ahead and deploy it in Azure. Where is that? Publish. It will ask for an Azure function app. So function app is nothing but the function host, which can have multiple functions. I'm not going to deploy it to Azure right now, but as you can see, since it's a .NET Core based Azure function version 3.0, I can run it on a Windows function app, or I can run it on a Linux. I can also run it in a container, but I can essentially have, just like how I have this function, I can have multiple other functions deployed under the same function app, and I can manage them and together as in a single in a single hold on. Okay. Yeah, so I was saying we can have multiple methods if we want to have in the same function app, so that we can manage them in single life cycle, but always follow the rule that all the related functions should only be there in a single function app. Don't put unrelated functions inside the single function app. I hope that gave you some context about how Azure Functions work. Uh, Moving on, there are some challenges that you will see as when you will use Azure Functions. Uh, for example, if you are running your Azure Functions independently, that is all right. But if you want to establish workflows, or if you want to call functions one after another, for example, what I'm seeing here, showing you here, the pattern is known as function chaining. If you want to chain your functions and execute function 2 once function 1 is over, then execute function 3 when function 2 is over. I'm not saying it's not doable using Azure Functions, but it becomes complicated. You can certainly introduce storage queues or any other queuing mechanism to pass on the messages from function 1 to function 2 and trigger them. But it remains tricky because function 1 will never know if function 2 was successful or not. Function 2 will never know if function 3 was successful or not. Likewise, if function 3 has an error, function 2 will never know about that. We can again utilize queuing for that, but it all becomes complicated and complex based on how many things we start including in our functions. To solve this problem, we'll talk about durable functions in a moment, but another pattern is fan out, fan in, what I'm showing you here. If we extend this function chaining pattern and start using function fan out, fan in pattern, that is again becomes so complicated if we use plain vanilla Azure Functions, just because of the complexity, because there is no state management between the functions. There are no error handlings in the workflow. The complex the workflow becomes, the complex your code becomes. And generally, each of the Azure functions, as I said, is meant for shorter executions. As I was saying initially, that each function should just do one thing. The moment we start creating complex workflows using vanilla Azure Functions, the execution duration starts increasing, which kills the purpose of using Azure Functions. So these are the four major drawbacks that I've observed using Azure Functions. If we are trying to define different patterns or complex workflows, that's where durable functions come into play, which is an extension on top of the Azure Functions. It lets us maintain state between different functions. We can define complex workflows using durable functions, and we can orchestrate we, different functions through an orchestrator function. What you are seeing is a plain basic durable function flow where we trigger an orchestrator function through what is known as a client function. Then an orchestrator function actually handles the workflow. It triggers the activity A function, then B, and then C. These activity A, B, and C functions can be executed in parallel, can be executed in sequence, or it could be any other pattern. This orchestrator is what makes durable functions solve all the challenges that we saw in the last slide for Azure Functions. Azure Durable Functions is built on top of open source framework known as Durable Task Framework. I'll provide the link for that towards the end of the slide deck. But if you want to check it out, how it has been implemented, it's available on GitHub. It's open source, so do check it out. What you are seeing here is client orchestrator, activity A, B, and C. This is just not limited to here. You can also have a sub orchestrator, meaning one orchestrator can trigger another sub orchestrator, which in turn can trigger other activities, sub activities. There is another type of function called as entity function, which helps us managing what are known as durable entities. I have a different slide and a demo for that, but essentially we can maintain those stateful or durable entities either through client or orchestrator function by calling these entity functions. This is essentially how it looks like. If you remember, we had queue trigger sample that I showed you earlier. We have a durable function here, and the magic happens through the orchestration client binding here. As you can see, apart from the queue trigger binding, there is also a iDurable orchestrator client attribute here, which adds the orchestration client binding to a function, indicating that it's a durable function. Now, this is the start method. I'm sorry. So this is the start client function, which had the orchestration client binding, and this is the actual orchestrator method or orchestrator function, which comes with an orchestration trigger, just like we had queue trigger here. So we define an orchestration client binding here on the client function, and then we define a function with an orchestration trigger attribute, which defines it's an orchestrator function. Likewise, for activity functions, we define or we decorate them with activity trigger attribute to indicate that those are activity functions. Let me go to Azure to my Azure VM and show you how we can get started with durable functions. And what I'm showing you here, you can essentially do everything using Visual Studio Code as well. There is not much difference. I'll go ahead and go use Azure Functions template. I'll give it a name, durable func. And I'll go ahead and use the template durable functions orchestration. This was not available, I guess, a year back. I have noticed when I started preparing for this session, it was available. I guess it was launched starting version 3. I'll use the storage emulator for now. Otherwise, as I said earlier in the Azure Functions demo, I can use a storage account as well. I'll go ahead and create. It will automatically create the boilerplate durable function for me. As you can see here, this is my client function, which is an HTTP trigger based. This is my orchestrator client function. It triggers my function 1, which is my orchestrator function here. And this is my orchestrator function with the orchestration trigger. And my client function triggers the orchestrator function using a method called start new async. And what it essentially does is it triggers my orchestrator and returns back an instance ID. And my client functions keep checking the status response from that instance using the instance ID and return once the orchestrator finishes. And going to the orchestrator, as I said, this is the orchestration trigger, which indicates this is the orchestrator function. It has 3 activity functions. It is calling 3 activity functions. Essentially the same activity function, but with the different parameter. Here is my activity function, function 1 hello, which is decorated with activity trigger. It takes a parameter name, which I'm passing in here, and it just returns hello, whatever name I pass on there. Here it will be hello Tokyo, hello Seattle, and hello London. And since this is an HTTP trigger function, it's easier for me to test it by just posting an making an HTTP call, but we can have any different kind of trigger here. I'll go ahead and run this. It will run essentially the same way. Close this one. As you see, it runs exactly in the same Azure Functions runtime, returns back a HTTP URL for me to go and trigger my durable function. I'll go and click on this, but since it fails because I did pass the names as well, I'm sorry. So I'll go ahead and see the status. As you will see what it returned, it returned few URIs to me. I will talk about this in the later slides, but Azure or durable functions come with that orchestration client binding, which comes with a REST API, which can be used to manage your durable function. So what I'm doing right now is I'm using the status query get URI link, which gives me the status of my durable function. Right now, when I did ran it first time, as you can see, it says it's running. I'll go ahead and refresh it. As you can see, it was completed. There, I didn't pass any inputs yet. And here was the output, hello Tokyo, hello Seattle, hello London. If I go back to my runtime, you can see the step-by-step logging of the different execution steps. As you see, saying hello to Tokyo, to Seattle, and to London. It did executed my 3 activity functions in sequence. Pretty straightforward. You can get started with a Azure function within a couple of minutes. That is awesome. Before I dive deep into more demos, I wanted to touch upon a few other concepts on durable functions. Here are some of the languages, programming languages that durable functions support, ranging from C#, JavaScript, Python, F#, PowerShell. It is still in public preview for PowerShell. You can always check out the link that I have provided here for an up-to-date list of supported languages. A task hub in durable function is a concept you should be aware of. Just like Azure Functions, durable functions utilizes Azure Storage as a backend, and it utilizes event sourcing pattern for updating the storage account, meaning it doesn't update any existing information. It just appends to the end of it. So what Task Hub does is Task Hubs provide logical containers for all the Azure storage resources that are consumed or used by your orchestrators. Now, what you're seeing here on the picture here is under your storage account. In my case, I was using Storage Emulator. I will show you how it looks like for me in my local environment. But essentially, under your storage account, there are different task hubs. You can either have one task hub like this one in your storage account, or you can share your storage account across different task hubs. The idea is any orchestrators and the underlying activities that needs to be integrated and talk to each other should exist in this single task hub. Any orchestrator sitting in task hub 1 cannot talk to an activity sitting in task hub 2 because they essentially are isolated from each other and they cannot see the state from each other. So here is how it works like if I go back to my this picture. So what I have there is, let's say we have a client and orchestrator, and then we have 3 activities, let's say 2 activities, activity A and B, that it executes in sequence. So you should be aware of how the durable functions orchestrators execute. Whenever the client function is triggered, it triggers the orchestrator function. The orchestrator functions get started. Orchestrator function, once it gets started, it goes and starts the first activity, and then orchestrator goes back to sleep. Once the activity 1 gets completed, orchestrator wakes up, checks the activity 1 status, it's completed, move on to activity 2, triggers it, and then goes back to sleep. Once activity 2 is completed, oops, that's a typo, but once activity 2 is completed, orchestrator wakes up again and executes from the starting again, seeing activity 1 and activity 2 are completed. Then orchestrator also gets completed. This is essentially how it looks like. I picked up a demo code from the same demo I was showing you earlier, that the boilerplate code that gets generated through uh, the function template. It's a function chaining template. As you can see, it's executing activity 1, 2, and 3 in sequence. So essentially what happens is when you execute this, it starts with the starting. It goes and executes or starts the activity 1 and then goes to sleep. The orchestrator goes to sleep. Once the activity 1 completes, it wakes up the orchestrator, and orchestrator again starts from the top. Then orchestrator comes to the activity 1, then goes back to task hub, checks the status of this activity and finds that that activity was completed in the last run. So it jumps onto the next activity and checks the status and finds that the activity was not executed last time. So it triggers that activity function and goes to sleep. Once the activity 2 gets completed, it wakes up the orchestrator, and orchestrator, like the last time, again starts from the top, comes back to activity 1, finds it to be already completed, moves to activity 2, finds it to be already completed, moves to activity 3 and finds it was not executed. It triggers the activity 3 function and then goes to sleep. Once activity 3 gets completed, it wakes up the orchestrator, and orchestrator again starts from the very top. And once all the activities are completed, the orchestrator returns. So this is essentially based on the event sourcing pattern that I was showing you. It always updates. It never updates the state. It always appends the state. A few things. Since durable functions support different programming languages, C# and Python and different other languages, so you can use all the native error handling features like try catch in your code to handle errors. Be aware that whenever an exception occurs in any of the activity, it throws an exception type called function failed exception. So you can catch that exception in your orchestrator function and do take a right action. Here is an example of how you can use your try catch block. If I have put my activity function execution in orchestration under try block, if anything happens, I can do anything in my catch and handle it graciously. You can also implement retry policies for handling transient failures. What I'm showing you here is an example of how you can set up a retry policy with tries 3 times every 5 seconds and for any transient failures. You can use a durable function, a durable timer to abandon a function call. If your orchestrator call is either hanged or it's taking too much of time to complete, you can use a durable timer to abandon a function call. You can go and check out the link that I have provided you there. I will show you another method using the REST API calls, how you can abandon an existing function call. As I was saying, functions REST API, those are used to perform management tasks on your orchestrations, entities, and task hubs. Webhooks, these are essentially webhooks, which are similar to your Azure Function APIs, which are authorized using the function host, but they are managed by the durable functions extension. There are different kind of REST APIs that you can consume. You can start orchestration, get the status of each of the orchestrator instance. You can purge history for your orchestrator, single instance or multiple instances. You can raise an external event for your orchestrator through raise event API. You can terminate an existing orchestration through API. And then the last three are for entity. You can durable entities. You can get the durable entity. You can list the entities. You can signal or pass on information to a durable entity. For any of these 9 API calls, you have to pass 3 parameters. These are 3 required parameters for all of these. Then there are some other additional parameters for each of the API calls. You can check out the link here, which has all the parameter definitions, which API call needs which parameter. But essentially, each of the API call either returns a 202 if it's accepted, or it returns a 400 if it's a bad request, if you have not found the request well. Let me go to the demo again, close this guy. What I did was I had this function chaining earlier. I did commented it out, and instead I went ahead and I created a person class with a property as name. And then what I'm doing is essentially I am reading a list of person as the body form from my client function, which is an HTTP trigger based function. So I'm passing a list of person with their names, and then I'm passing that person's list to my durable function, which gets triggered through start new async. Then in my orchestrator function, I am looping through all my list of persons. I'm getting each individual person and then passing his name into my activity function, which is essentially saying hello to the person. So essentially the same function that we had function chaining earlier, calling the same activity for different names. Now I did implemented a loop, and I'm rather than passing individual names, I'm passing a list of names. Let me go ahead and trigger this and run this locally. I'll pull up Postman. Here's the URL for my HTTP function. I'll go here and I will go ahead and pass a body for it. Go ahead and trigger it. As you can see, it did return all those 4 URLs that it returned earlier in the earlier demo. If I go back here, as you can see, it did triggered my durable function. It says hello to Weber, Ryan, it's still executing. If I go ahead and get the status for my function, it will say it's still running. That's what I can see here. It's still executing for different names that I have passed in my body. I'll keep checking once my function gets completed. It is still executing. It got completed, and you can see the output that it returned. Here was the input that I passed. I did pass 4 different names in the list, and it did return the output. I will go back and show you how we can terminate an existing durable function. Let me go ahead and pass on a bigger list of names so that it takes some time to execute. I'll go ahead and pass on the updated body. I'll go ahead and click on send. As you can see, it has started executing again. I'll go ahead and click here and get the status. It says it's running. Now you will see here there is a terminate post URI. I'll capture that to terminate my ongoing orchestration. I'll pass the reason why I want to. I'll say cancel this run, and I will send this. Oops, it will be a post call. It's 401 gone. Looks like my function was already completed. I'll go ahead and put a debug point here so that I can stop it in between and I can terminate. I'll go ahead and close this and trigger this again. It will go back to my function. I'll execute it once. It has thrown me my status URI. I'll go ahead and execute this. It will have hit my debugging point. I'll go ahead and run it. And as you can see, it is still running. I'll go ahead and pull up this. I'll go ahead and provide a reason for terminating my run. And before I can do so, I'll go ahead and remove this debugging point and click on that. I'll go back here and click on this. Psh. So it was accepted this time. If I'll go back and look at my status, it will say it is now terminated, not completed, not running, but it's terminated. If I'll go back in my runtime, I can see that it got terminated. As you can see, the status is terminated. I'll go back here. I want to show you one more thing, exactly the life cycle that I was showing you earlier, how durable functions get executed. I'll go ahead and put a debugging point here and run the original demo that I created first for function chaining. Go ahead and put this here. As you will see, let me go ahead and step over. You will think that it is gonna go to next activity, but it's not gonna do so because it triggered activity 1. It went back and started from again because orchestrator went into a sleep mode and then it woke up and started afresh. Now it will go back and check activity 1 status and see that activity 1 was executed. Then it will go and execute activity 2 and it went to sleep, triggered activity 2 and started afresh. And if I will see, next time it found activity 2 was also completed, it goes ahead and triggers activity 3, goes to sleep, and then once activity 3 was completed, it wakes up and it executes the same thing that I was showing you in this slide. I'll stop this guy here. Moving on, I did show you function chaining, how it works. We can call activity in sequence, one activity after another activity through different activity functions. This is the exactly same code that I was showing you. And then we can also implement fan out and fan in. So this is an example I'll show you quickly in a demo, but essentially we create a list of parallel tasks and then we execute a when all so that it waits for all the parallel tasks to execute. We can also implement a pattern called as async HTTP API. Sometimes durable functions workflow might take time to execute, so we can have a start HTTP function which can return back a correlation ID back to the caller and then trigger the activity, and then the calling API caller of the API can go back and use that correlation ID to get status through the state of the durable function. There's another pattern called as monitor, where we can actually keep monitoring the status of an existing function and keep polling on that, which works through a monitor pattern. We do utilize monitor method when we want to monitor or poll into a different activity which might take time. We can keep, and which doesn't returns back to us directly. So this is how we can implement it. We can trigger an activity for, let's say, get job status, and it returns back a job status as a string. And if it is completed, we call a different activity for sending alert. Otherwise, here's the trick. It goes ahead and it makes the orchestrator to go to sleep for a certain number of seconds. And then when it comes back, it again checks if the current time is less than expiry time, then it goes ahead and does the other thing, the same thing again. Otherwise, if it's already expired, the orchestrator exits. Similarly, there is another pattern called human interaction. Sometimes in our workflow, we might need humans to go and interact with the workflow. We can implement them easily through durable functions pattern. We can use function which is part of orchestrator client binding called as wait for external event. And we can use raised event async API call to pass on an external event back to our orchestrator. And in this case, it might return a Boolean variable for whether it's approved or not. And based on that, we can do our execution for the function. I had created a couple of demos for this. You have already seen function chaining here. So I will not do this again, but I'll jump on to fan out, fan in. Essentially, what I have is I have a temp folder here, which has some temporary files. Here's my storage account, which is connected to the emulator, as I was showing you in my slide about task hub. You will see all my task hub are called as test hub. There are a couple of tables under test hub name history. You can see the history of my orchestrator and execution. And under the instances, it logs all the different instances of my orchestrator that have run. So you can see all the history. This was the last execution that I did for one of my functions. Anyways, I will go ahead and trigger fan out, fan in. What it essentially does is it reads my root directory where all the files are located. It calls an to get file list. It gets a list through an activity function. It does calls directory.get files and get all the directories, all the files which are present in my directory. It runs through those files and triggers another activity for copying that file to blob, which essentially takes each of the file and dumps it into the blob storage. It just adds it into a list of tasks, and then it goes ahead and wait for all the parallel tasks to complete. I'll go ahead and run this Azure function, which implements fan out, fan in. I'll go ahead and copy this and trigger it from here. Oops. Okay. I'll see. Demo gods. Did it go through this time? Oh, it's doing. I don't know why it failed for first time, but it is now copying, I believe. And it's copying all my files. I guess I have made some changes which might be returning in some errors, but it is actually copying all my files. I'll go ahead and refresh my emulator blob container, and here is my backup storage blob storage container where all the files have been copied. It's pretty straightforward. We can extend it to any asynchronous task and have our own fan out, fan in pattern. Another thing I was mentioning about was durable entities, where we can read and update small pieces of states, which are known as durable entities. Comes with a special trigger type entity trigger, just like we had orchestration trigger. We have, activity trigger. This comes with an entity trigger. These entity functions actually manage the state of an entity explicitly. It offers methods that we can use like set state, get state to manage, to store and read our state from the task hub. Entity functions are only supported in durable functions 2.0 and above, since it's based on .NET Core. It doesn't work on the .NET Durable Functions 1.0. So essentially, this is how the code looks like for an entity function. Here, I am maintaining an entity called as counter, which for which I get an entity ID for my state. And then I'm checking, reading the current value every time I execute my entity function. If the value is less than 10, I send a signal to my entity to update my counter by 1. If it is more than 10, it doesn't update it going forward. This is how I've defined the counter entity. It comes with 3 different methods: add, reset, and get. I didn't call reset method here, but we can call reset to set the state to 0. Add method adds, increments it based on the input value that we are passing here. In this case, we are passing 1, and get gets the current state of that. And this is where we are defining the entity trigger. It indicates this is an durable entity. And I have this demo as well, where as you can see here, this is my durable entity, where I have exactly the same thing I was showing you on this slide. It comes with an entity trigger to indicate it's a durable entity. I have added 3 methods. This is my orchestrator function, which essentially calls my entity function using call entity async method. I'll go ahead and run this. And I will put a debug point here. See, once it's up and running, I'll go ahead and capture. Every time I'm using HTTP trigger because it's easier for testing, but you can use any other kind of trigger for your use case. As you can see, the current value is coming as 4 because when I was preparing for demo, I already ran it for 3 times. I'll go ahead and click on execute. I'll go ahead and refresh it. So it will increment it to 5. And this state is getting saved again in where is that? It gets saved somewhere in the storage account. But you don't have to essentially worry about the nitty-gritties of how it works in storage account, but that is how the durable entities work. You can essentially save your states or different entities as states in your task hub using this particular pattern. Using call entity async method, you can call the entity and you can define how you can set or get state for your entity. Durable HTTP, you should be aware of that when we are using durable functions, the orchestrator functions cannot perform any I/O operations directly. You should defer those operations to activity functions. But starting durable functions 2.0, you can actually call HTTP APIs and defer the I/O operations to the HTTP API. What you are seeing here is essentially in your orchestrator, you can make calls to your HTTP APIs. It could be get, post, on any other function, any other HTTP action that you can call. Now, there might be situations when you might have to run background jobs which are never ending or which might need infinite loop, you can use something known as eternal orchestrators. You can use a method called continue as new and pass a null parameter. What really changes is in your client function. If you will notice earlier when I was showing when we called start new as sync, it returns an instance ID every time you trigger an uh, orchestrator, but this time instead of it returning back an instance ID to you, use pass on the instance ID so that you can always trigger the same orchestrator infinitely. Last but not the least, you also might have situations where you might have to run background jobs which only need a singleton instance of your orchestrator. You can implement singleton pattern in your orchestrator as well. You can always check for your orchestrator instance. If it is not completed, failed, or terminated, uh, you can stop running, or you can create a new instance, sorry. Otherwise, if it already exists, you can utilize that existing singleton instance. As I was saying, there are certain limitations. Orchestrator functions can call only deterministic APIs. Deterministic APIs are the APIs that always return the same values given the same input, no matter when or how often it is called. Some of the APIs which might not return you the same value, which are non-deterministic, include the ones which return current date and time, because date and time might change. Current date and time might change depending on when you make a call. GUID generators might be another area. So check out the link I have provided here to look into some of the non-deterministic APIs that you should not call in your durable functions, because it might break your replay behavior or how your durable functions workflow takes place. In the link, Microsoft has also provided certain workarounds to make those non-deterministic API replacements in your code. And then we did talk about the eternal orchestrations, or there are situations where orchestrations might take time and you, being a developer, can push a code change in between. So always remember that if you push a code change when your orchestration is in process, it might break your replay behavior. It may break your orchestrator workflow. So always terminate your orchestration before you push your code updates. Otherwise, you might have to have a plan to handle the failures. Lastly, I did mention in one of the earlier slides, orchestrators can do input out IO operations directly. Instead, they call activities to do so. You can also use durable HTTP calls to make to defer the IO operations to external HTTP calls. Well, that's pretty much it's. Here are some of the resources that you can refer to. I provided some links from Microsoft documentation that might be helpful. I did took most of the samples from Microsoft's website, so that if you want to try it at your end, you can get it from there. Here's the YouTube channel for Azure Functions, a team that do publish certain videos on Azure Functions. They also publish, I believe, their stand-up videos or their roadmap videos. If you are interested in Azure Functions, I would encourage you to subscribe to that. And here's a link to the durable task framework on which Azure durable functions are based on. With that, I can open the floor for any questions or comments that anyone might have. I don't see anything on the comment. Feel
We
free.
have one hand up.
Go ahead, Venkatesh.
Uh, Hey Vaibhav, thanks for the great presentation. I have a question. So, if there is any exception on one of the activities, whether the orchestrator it stops or is it continue with the next activity?
It, I think it stops.
I think it'll ultimately terminate the activity.
That's
or
right.
if it has an unhandled exception.
Yeah,
But
that's why we should implement it. I think the question is if we don't have exception handling and if the activity fails. will the orchestrator continue? I believe it will not. I didn't try that, but I believe it will not. And that's why it's suggested you should have exception handling. You can handle exceptions individually at the activities level, or you can also handle exceptions at the orchestrator level. Because essentially when your activity functions will throw exceptions, that is of a specific exception type that you can catch in your orchestrator function, and then you can handle that in the catch block in there, or otherwise you can handle it in the individual activity function as well.
Even if we have that catch block and handle the exception, will that still continue to run and execute the other activities?
Uh, if you, I mean, I'm not seen an activity throwing an unhandled exception unless I go ahead and explicitly throw an unhandled exception through my activity function. Might be a case, but by default, what I've understood is it always returns back a specific failed function failed exception. But I don't know. I'll check it out and get back to you. I have not tried that particular thing, but my understanding is if we don't have try catch, it will fail. If we have try catch, it will not fail. It will continue.
I think as always, it depends on your circumstances, probably what it is that you're exactly doing inside the try catch, right?
That's fine. And if I throw that exception, it might fail, but.
Thank you. Thank you for the explanation.
Because the try catch, how if let's consider a scenario. Let's say you have an e-commerce application where you have, let's say, an order application where someone placed order but it didn't get shipped. So what happens if there was an error when the order was not shipped in the shipping function, but the order was placed? So probably you can catch that in your orchestrator function and get the order canceled because it cannot be shipped or something. So it depends on use case, I guess, and how you are handling the catch. It will not, to answer your question, I think it will not continue to the next activity. It will handle it graciously. That's where I was saying it will handle. You can utilize the existing programming language constructs to handle exceptions.
So probably like it will handle the exception graciously and then complete the execution.
It will complete the execution. It won't go to the next activity because it would be already out of try block.
Thank you.
Anybody know why you wouldn't be able to use non-deterministic functions? Yeah, take an example of current date and time. If you have a situation where you are in the same execution of your orchestrator, then current date and time, every time you make a call to a non-deterministic API, it will return a different timestamp.
Yeah, I think one thing that really confused me about durable functions when I got started was the fact that they were reentrant, so that the code will be executed, or the activity functions can be executed multiple times, when in reality, it looks like they're going to be executed once, but as soon as you hit that first await, it's going to exit the function and then come back in after it finishes, flow through that, and then continue on.
Orchestrator goes into a sleep mode and then again wakes up and start from the starting.
Yep. Yeah, it took me a while to wrap my head around that concept.
So it does maintains the state based on event sourcing in the storage account. It logs each and every state whenever activity is started. If it doesn't find activity completed, it again calls that activity function. Yeah, check out the link. I'll probably share the slide deck with Matt. He can publish it on the website. You can check it out, the links that I've used.
The best place for you to share that is probably either in the chat here or on our Slack channel.
Yeah, I'll post it on the Slack channel.
Okay. Any other questions for Vaibhav?
I kind of have one, but it's more around the scaling. I joined the meeting today because I've got something coming up very similar for this, where I'm going to use functions to do it. And I'm kind of looking at the scaling. So imagine n number of clients, and I may use the same source code for each client, and each function would, to me, seems perfect because I may have one client that's super busy and super chatty, a lot of activity, and others that are dormant. So I'm just curious if you guys have done any of that work where you've had numerous clients in a scaling situation where then I can turn around and bill based on that scaling, right? That's my intention. Like customer A won't get charged the same as customer B because they're more voluminous. So I don't know if anybody's had any experience trying to model that, but that's where I'm heading.
And I'm trying to relate to what you are looking for because can you
like your demo here is like you're looking at the scaling versus the plan, right?
Mhm.
And so imagine that times n. I have n number of customers. They all use the same code base. It's just configured differently. And customer A may do 1,000 transactions an hour, and customer B does 10, right? So this is starting for me in my head to build a model of if I use a function to run this executable, and customer A is more voluminous than B, then I could build a billing plan based on that scalability. So take your example and multiply it by n. I'm just curious if anybody's ever tried that. Has that model worked for anybody?
So I think one of the big advantages with, and I don't think we're talking about durable functions here, but I think one of the big advantages with functions in general is their ability to scale unlimited. So it doesn't really matter how much traffic you show at it or throw at it, it will just continue to execute.
Yeah, I get that's scaling on volume for a particular function, right? I'm talking more about, let's say I have 100 Azure functions, but
Right.
under the hood, they're all running the same code, right? It's the same exe that's just configured differently for each client. And client A, client B, client C may have different throughputs, right? I might not have as many requests or might not have as much memory usage due to data flow. So do you guys think it would be easy in Azure to scale that from a billable perspective, right? Let's say I have 100 of them running. I got to figure out how to charge customer A versus customer B, right? So that scaling model of each instance, not necessarily scaling out resources to let that function run, but scaling multiple functions.
I think almost what it sounds like you're talking about to me is deploying multiple instances and
multiple functions. Like, so function A and function B are theoretically the same. They're just configured different. They might have a different connection string and a different API implementation, right? But ultimately, it's the same code under the hood.
right.
I'm just saying. Go ahead.
And the same code part is what makes me think multiple instances. So you say it had the same code, just deployed multiple times. But then that becomes kind of a challenge because it kind of implies that you're deploying it once per customer. And if you have 10 customers, it's manageable. But if you have 10,000 customers, all of a sudden it becomes a little bit.
Yeah, then storage space becomes a problem. Yeah, so this is why, because I need to think about all these.
Yeah. Well, not just the storage space, but the ability to deploy all of that. I mean, when you make an update, you don't want to have to deploy 10,000 times.
No. And I've broken out into NuGets, so each client can upgrade at their own pace. So if I do a breaking change, it's not a big deal. But yeah, no, that's a good point.
Do you need each client to have their own version?
I could, yes, I could.
Oh, that makes it more interesting.
Yeah. I have some that are, we do it once and we're done. They sign off and we never see it again. And others that keep changing. I mean, we all know the business, right? Some are easy and some are not.
Yeah. I would try to make those things configurable as much as you can. Make those changes configurable. That way you can apply it to the same code base to different clients.
Yeah, I wonder if it's probably more prudent to look at maybe more of a what would I call that?
Multi-tenant solution.
Yes. Yep.
Yeah.
Okay.
And it depends on, there's a whole lot of things that factor into it. I mean, at the end of the day, it might be less work and cheaper just to deploy them all in the same thing and kind of figure out what their slice of the pie is.
Yeah, and that's where I'm trying to get. Like, how do I build customer A versus B, right? And maybe I just look at tiering out Azure a little more to accomplish that. But
I think that's always gonna be tricky for consumption-based plans. You can instead then start looking at app service plans, running it on dedicated plans, probably a separate plan for each of the client, and then you can always resize them based on what's the requirement for.
There
But
you
then
go.
that will kill the purpose of the true serverless because it will have dedicated
Yep.
servers. So
Yeah. I mean, billing does play, right? I gotta think about the number of clients, but cool.
Yeah.
Awesome.
Yeah, unlimited scale equals unlimited cost.
As long as I don't incur it and I can figure out a way to push it on accordingly, then I'm okay.
don't have a function that runs 24 hours.
Yep.
I'd almost, in that scenario, I'd almost wonder if you could say 90% of the customers have average use.
Yep.
So we're going to throw them all on one pool and just, divvy up that pool based on, there's 10 people on there, so everybody pays 10%. And,
Yeah.
maybe one uses 11, maybe one uses 9, but they're close enough to 10%. So just charge them 10%. But then maybe there's a handful of customers that are extremely high use. Then it might make sense to throw those on their own dedicated systems where you charge them specifically.
Okay.
Yeah, I'd say if you're interested in this, go out to the Slack channel and post something in the tech, the tech discussion area, because I bet that would drive some discussion.
Cool. Can you forward that to me, Matt? Do you have my email?
If you just check out the any of the subscriptions or the emails that I've sent out, it's linked at the very bottom.
Oh, it's in there. Okay.
Yep.
Perfect. Cool. Thanks, guys. Appreciate it.
Yep.
All right. If you have any questions for me, feel free to reach out to me on Twitter or LinkedIn. But I'm also on the Slack group for this user group. So if you have any questions, you can reach out to me there as well. Thank you once again, everyone, for joining. Stay safe, stay healthy.